Hey, we just got to 5:05. Thank you everyone for joining us. I know we've got kind of a smaller group than usual, but just as a reminder, we are your host for the webinar series. I'm Samantha Leave, the Director of Policy for DS4E. We also have Lee Ellen, our Partnerships Manager from DS4E, Katrina, the Mathematics Instructional Coordinator for Montana OPI, and Amy, our Professional Learning Manager from Montana OPI. We're really excited to have everyone here today, and we're also excited to invite our guest speaker, Aaron Reedy. He's the co-founder and CEO of Data Classroom. Aaron, I'd like to invite you to introduce yourself.
Sure. Yeah, I'm Aaron, everyone. I am formerly a high school science teacher in the Chicago Public Schools. I left the classroom in 2012 to begin work on a PhD in evolutionary ecology. Um, and along the way in graduate school, I got pretty deep on thinking about what would be the best set of data tools for kids, because often when we would do lab experiments where we were collecting data in my class, that was when enthusiasm was at its peak. And when it came time for graphing and sense making of the data, I often found that we were lacking, and I've been working on how to make that moment better ever since.
Thank you, Aaron. And we'll dive right in. Lee Ellen, do you want to take over?
Sure, yes. So excited to talk to you a little bit about data visualizations today. When you Google data visualizations, the definition offered from the Oxford Languages Dictionary is the representation of information in the form of a chart, diagram, picture, etc., or a chart, diagram, picture, etc., that is created as a visual representation of information. So a data visualization, put simply, is a way to represent information or data to make it easier to understand. So a few examples of data visualizations, as you can see, are bar charts, line graphs, pie charts, heat maps, bubble charts, and many others as well. Next slide. So why do we need data visualizations? This diagram gives a few explanations, but I'm going to narrate those just a little bit. Data visualization is essential for understanding and communicating information effectively. They provide faster insights by revealing patterns and trends. So they identify trends, relationships, and patterns that are not as easily seen in raw data or tables. They aid in better decision-making by telling a clear story. So data visuals guide the audience through the information step by step, making it easier to reach conclusions and make informed decisions. They simplify complex data. They turn large and complicated data into visual formats like charts and graphs, making the information easier to understand. They improve communication. It makes it easier to explain data insights to others, especially those who may not be familiar with the technical details. And then finally, time efficiency. It helps you save time. So visuals allow quicker interpretation of data, helping users spot key information at a glance instead of manually scanning through numbers. Next slide. So what is a visualization? Or let's take a quick look at an example of this. Here we see a data table with the top 10 counties in Montana from 2023 ordered by population distribution. If students were to look at this data table, they can see the numbers in descending order. But now let's take a look at the same information when it's put into a data visualization or a heat map. When students are looking at that map, hopefully they can get a much better gauge of the populations by county at a glance, rather than having to really sit and parse through a data table, trying to think about which counties have the highest or lowest populations. So seeing this information visually helps them connect with it in a different way because they can probably relate to the more heavily populated areas when they see them on a map, knowing what's located in those areas. So this is just one quick example of a data visualization and how we can make data easier for our students to consume. And now I'm going to turn it over to our expert, Aaron, who's going to show you how you and your students can create data visualizations within Data Classroom. Aaron, over to you.
Great. Thanks, Leon. And I've got my screen share up and you can all see me there and the slide as well. I am gonna first just start out by going over a couple of reasons why I think data visualization should really be a part of just about all data work. And I mean, if Data Classroom as a tool has a perspective or a point of view, it is that data work should start with visualization. Um, I'm going to go through three kind of examples of this to help make my case and illustrate for you why data visualization could be so important for a variety of reasons. And number one is that there could be a dinosaur hiding in your data. My PhD advisor always said to me that he didn't want to see any numbers until he could see a data figure. So that was really an integral part of my training in learning to work with data is that you would visualize your data first. And so we'll take a look at some data and go hunting for a dinosaur that might be hiding in there. Number two, I think that graphs help you ask the right question often. I know that as a good scientist, you are not supposed to find your hypothesis in your data. But I do think that your data and a visualization of your data can be used to help you refine your questions and often lead you to new questions or new ways to ask those questions. And then number three, I think intentional graphs speak both loudly and clearly. And I'm going to talk about what I think is the difference between a graph that is speaking loud and a graph that is speaking clear. And I would endeavor to do both of those things. And if you can, train students to do both of those things as well. I'm going to be using the Data Classroom tool to illustrate these concepts. That doesn't mean these are concepts that only apply to the Data Classroom tool. These are sort of perspectives that I think hold true no matter what you're using to work with your data. If you are interested in opening up Data Classroom and following along and doing some of the same playing with data that I'm doing in the same way that I'm doing it, you can scan this QR code to get 60 days of access to all features on Data Classroom. And I also want to say that we are a freemium tool, and there is a heck of a lot you can do for free on there, even when that 60-day trial is up. So with that, I'm going to actually stop my share for just a second, and I'm going to transition over to a window that has Data Classroom on it. And how did that work with the share as presenter? Did you all feel like that looked good? Okay, we're going to do that again with the little me on top of the screen there. Okay. So you are now looking at my Data Classroom dashboard. This is kind of the main navigation area of the web app. There's a resource library of data sets, and you can get to that by clicking on that big band of colorful tiles up at the top. But I've actually kind of prepared a data set exactly the way I want it for this presentation. So I'm just going to go down to my list of recently visited items, and I'm going to open up this version of the Datasaurus dozen here. This is a really interesting data set. We have a version of this in the resource library that a student could do as an individual. We also have a version of it that teachers could deploy with groups of students, up to 12 groups of students. So you could do this as a whole in-class activity if you wanted. I'm not going to be doing the entire activity, but I'm going to kind of tell you what the data source dozen are all about. And this is a data set that has been specifically made to illustrate why graphing and data visualization are so important. As I scroll through the data set here, this data set has 1,846 rows of data in it, and it's broken up into these subsets that are these data samples, and they are listed as A, B, C, D, etc. On here. And I'm going to go over to the graphing part of the data classroom tool, and we're going to start exploring these data. So I'm going to add first just this Y variable and look at a visualization of this variable called Y variable across all 1,846 rows of data in the data set. And you can see I've used these semi-transparent points so that you can see where the data is more dense, and those are the areas where it's darker, and where the data is less dense, and that's where it gets thin. And you can particularly see that at the two ends. But if you look carefully, you can kind of see some bands in there where data are stacked on top of one another. I could go ahead and look at the descriptive statistics for this, and I'm just checking this box over to the right, and I'm going to get the table of values for that. And we can see that the mean in this data set, which is visualized with that little blue dot off to the left, that is 47.8, and the standard deviation is 26.8. Now, an interesting thing about this data set is I'm going to look at this variable called data sample for a second, and I'm just going to pop this open so we can look, and we see we have these groups A through M here. And what I'm going to do is I'm going to exclude all of them except the M group. So I'm checking these boxes to exclude these. And there are numerous ways you can filter your data in Data Classroom. This is just a very transparent one where you can see exactly what I'm doing. So I chose to go here. And then I'm going to apply this filter. And now we're looking at just the data points for that Y variable for that M data sample group. And it's interesting that you notice that this mean hardly changed, right? I can't actually remember what it was before. Was it 47.8 exactly? It was something, it was either that or it was very close to it. And the same with the standard deviation is 26.9. So mean of 47.8, standard deviation of 26.9. I'm gonna now focus in on a different group. So instead of M, we're gonna look at L. So I excluded M and I included L. And I'm going to look at this again, and we see the mean is unchanged, right? So different group of data, same mean, same standard deviation, but they're not the same data set, right? And if we were just looking at the numbers, those descriptive statistics, we might conclude that these were exactly the same. And you also might be saying, well, they don't look that different to me right now, right? But I'm going to go ahead and add this variable called X variable. So with this particular set, right, we can see the XY plot with the X variable on X, the Y variable on Y. And we look at this, we can see the distribution right away. We see this interesting pattern where it looks like we have these bands that go kind of diagonally repeating across the screen. I'm going to add a regression line, and I'm just adding this off to the right of the graph. You'll see there's that box where I can add a regression line. And so I added a line of best fit. We can see the equation for that line. We can see that the slope is a negative 0.11, and the R squared is a 0.004 there. I'm going to go ahead and now look at a different group of data. So we were just looking at the L group. I'm going to look at the M group, and we can look at it again, and we see that the slope is almost the same. It's just slightly different. Instead of a negative 0.11, it's a negative 0.106. So very, very close to the same slope. The R squared value, 0.004, is almost identical. But when you just look at the plot with your eyes and you look at what's going on, it's a completely different set of data. It's a completely different distribution. And we wouldn't have realized that if we were just looking at parameters like the mean, the standard deviation, the R squared, the slope of the line of best fit. That was, that was completely obscured. And each of these groups in here all have the same mean, standard deviation, slope, R squared. And there's one group in particular, this A group. When we look at this, we will see we do in fact have a dinosaur hiding in the data. And even this dinosaur, which is a clearly contrived XY plot, it has the exact same parameters. So the mean of Y is the same, the standard deviation is the same, the slope of that line of best fit, I'll bring it back. It's almost the same. It's a negative 0.103. The R squared is still a 0.004. So there's a lot about the data that you can get from a data visualization that you simply cannot get just from the numbers. So sometimes there is a dinosaur hiding in your data. Okay, for my next example, and I want to illustrate that graphs can help you ask the right questions. I'm going to leave this data set and I'm going to go to the data classroom resource library. This is a collection of curated data sets that have activities that go with them. There was an activity for that data source dozen. We didn't even look at the student facing assignment, but that's in there if you think that's an interesting data set to work with. But I am going to pull up this data set that's called Early Spring in Kyoto, Cherry Tree Blossom Dates, Historical Data. So I'm going to open up this data set. And this, I want to illustrate how graphs can sometimes help you ask the right questions or help you refine your questions. This data set is really interesting. Every year since about the year 812, the Japanese have been recording the first date of full flowering. And I believe that's defined, and that's in the assignment here, but I believe that's defined when at least half of the blooms on the cherry trees are open. We're into full flowering date. And every year they simply recorded that data of when that date was. And if we look at the data for full flowering date, we can see that the overall through this whole data set encompassing hundreds of years, the average day of first flowering is day 104. And to give you some reference on that, the days are January 1st is day number 1, and December 31st would be day 365. And so you can see this day 104 is April 14th. That is the average day. And you can see we have a lot of data here, and it ranges. It looks like the latest the cherry trees have ever been in full flowering is day 128, which is May 8th. And the earliest recorded date is day 86. That's March 26th. So you can see kind of the range. And when we look at this historically over time, we can see this pattern. And this right here is interesting because if you ask students to make a hypothesis about this, they will usually or quite often hypothesize that the date of full flowering and hence the start of spring is probably moving forward due to climate change, right? This sort of matches with a lot of the science that we've heard a lot about, a lot of high profile science that is very concerning to a lot of us. And if we add a regression line to this, we see that there is a slight negative slope indicating that date of full flowering is moving forward just a little bit, but it is very, very close to a flat line. And the R squared value indicates that less than 1% of the variation in flowering date is explained by the passage of time across this data set. And so this is a bit of a surprise result from what you might expect. But with our data set and with data visualization, we can explore this a little bit further. And if I add time period, and you can see I have in this control panel at the right, you can see what's on X and Y are in red, and Z controls this legend. And when I add time period as my Z variable, now we've color coded the data, and we've color coded it into these two periods, the post-industrialization, so everything from 1850 to present, and the pre-industrialization period, everything before that. And when we actually fit separate models here and we look at the slope of the change over time that's occurring, we see two very different patterns. And it is through that act of data visualization that you can get the idea to say, well, wait a second, let me just look for this specific time period. And if I actually go ahead and go back and use the exclude in much the same way that I did with the Datasaurus data set, I can look, this is what's going on in the post-industrial time period with flowering date. And we see that, at the beginning in 1850, the best prediction for, first flowering date would be somewhere here around day 108. But at the end of this data set, 2021, the prediction is somewhere around day 97. So that has, that date of first flowering has actually moved forward by 11 days, or the best prediction that a model could give us of first flowering date has moved forward by about 11 days since 1850. And this tells a very different story. And it's, because the first question of, how has the date of flowering changed since the year 812? That was one question, but it wasn't the most interesting question. And that question kind of pops out at you when we were looking at just that post-industrial time period. And again, I'll put all the data back up, but leave it color coded. And we can see that in the blue period, the more modern period, it's interesting to ask, wait, that looks like there's a big change there. What is that change? We can describe that with a linear regression model. And again, I think data visualization can sometimes help you pull out a more interesting question there. And again, just to, I didn't exactly do the student assignment, but those are basically the steps that a student would recreate. And that's the aha moment a student would have. This is the student-facing assignment where it gives them a little bit of background. It explains what the variables mean, and then they work through the activity and graph making there step-by-step, kind of how I did there. Okay, and so I have sort of one more story to tell here, and this is about how I think that data visualization can allow you to speak loud and clear with a graph. And I'm going to pull another data set out of the resource library. This is data from a somewhat recent experiment that was published in the scientific literature within the last decade or so. So this is fairly recent science. And oh, sorry, actually, I'm going to pull up a custom version of this because I made some changes. So let me go back to my dashboard, and I'm going to pull up this life on the edge, biodiversity in coastal habitats of Nova Scotia. And I've named it default graph because I want to use this to illustrate a point. And I'm gonna go ahead and show you this default graph, which I've pulled up here. This is a pretty typical default graph for a dot plot like this. In a lot of softwares, this would be sort of the default. I will say in Data Classroom, I had to sort of ugly up the default a little bit. I had to take away some color and make it a little bit less visually appealing. But this is a pretty standard kind of default-esque graph. And this experiment was simple. Scientists were looking at both habitats that were exposed to the full force of waves from the Atlantic Ocean, and that they defined or they called those the exposed habitats. And then sheltered habitats were habitats that were not facing the open ocean, but were on the backside of large rocks that were breaking the waves. And then scientists were measuring biodiversity in small quadrats in both of those habitats. And they were measuring the number of species there, calculating an index called species richness, and that's the data you see here. And the you can draw the conclusion from this that the exposed habitats tended to have higher species richness, and there's nothing technically wrong with this graph. I think this graph is clear, but it's not loud. And so some things that I would do if I was going to make this graph speak more loudly is I would start playing with color and spacing and labels to make this a little bit more clear of a picture. So some things that I would do is I would pick some custom colors. I might do some semi-transparent points there, and then I would choose a distinctly different color for the other group. And then I would probably make it semi-transparent to match. And then that's my first change. Another change I would make, and I'm going to open up the appearance menu over here on the right, and we're gonna change a lot of things here. So one, I would make these data points bigger. There's not that much data in this experiment, and so I can make these fairly large. I have plenty of space to work with, but I can still see the points, and the semi-transparent nature, lets me see those. So I can see my points clearly. I might drop my grid lines on here because I think it's just a little busy. I might even drop the edges all the way off the points and go with this. And then I'm going to set this up to do something that is going to highlight my difference in means, which when you think about speaking loudly with a graph, you want to think about what is the main story or the main point that you're trying to get across. And the main point here is that we have a difference between these two groups, right? The exposed habitat has greater species richness than the sheltered. So I want to do something to emphasize that. And it's fine to show the raw points. I actually think that's really valuable. You can tell a little bit about the distribution. You can tell a little bit about the sample size, but adding those big chunky bars to show the average, that really hammers home that, hey, this green bar is taller than this blue bar, right? There's a difference here. Another thing I would do is I would make these labels much larger. Again, if you want people to read something, then you should make it very, very easy to read. So I'm gonna crank up my axis label size pretty large so we can see those. And then even the markers, so where the labels for the two treatments, I'm going to make those a bit larger, and maybe my numbers. The actual numbers are maybe the thing that aren't as important to make super big and super readable, because I think you want people to get the story more than you want them to get the actual values of species richness. And then the last thing I would do here is I would think about the dimensions of this graph. And if you're trying to emphasize a difference that you're illustrating in that vertical plane, the difference between the heights of those bars, I'm going to take my graph and I'm going to scrunch it up so that it's more of a rectangle shape like that. And that's the final figure. I would copy that to my clipboard, and that's the figure that's going to go, in my lab report or in my publication. And that's what I would want to show. And so kind of going back to that in summary, I would say, don't show just the default when you could make a graph that speaks both clearly and loudly. And are you seeing my slides again? Did my screen share track over? Yeah, okay. And so, this is really close to that final graph that I produced there. But I wanted to show you again all of those things that I consciously did before my graph was ready for final sharing and final publication, right? It isn't just use the computer, have it spit out a graph. If you're communicating with data, then go ahead and communicate with data. Color and space and labels, these are the tools that you can use and you want to be intentional with your graph. And I think there's a lot to gain as a student researcher, as a scientist, just as a kid doing your homework in math class or science class. You want to be able to, to communicate that point. And certainly in the world of work, there are all sorts of ways where people need to communicate with data. So this is a valuable skill for students to get. Okay, so that we went through all three of my stories there. Things could be hiding in your data. Graphs can help you ask the right question, and graphs can speak loudly and clearly. If you're interested in playing around with Data Classroom on your own, there's that QR code again for a 60-day free trial of everything on Data Classroom. And happy graphing, everyone.
That is great. Thank you, Erin. I love that. I love finding the dinosaur in the data. And when you flipped the line of best fit and saw that in the two colors of the cherry blossoms, that was really fascinating as well. So love that. Thank you.
You're welcome. Thanks.
All right, we are going to talk through a few other tools and approaches to building data visualizations. You've seen a fabulous tool already. If Sam, if you'll go to the next slide, this is a tool that we've touched on some of our other webinars. So if you have joined any of the other webinars in our series, we won't spend a lot of time on this, but it is one of our favorite tools. So we always have to talk about it, especially when we're talking about data visualizations. This is the slow reveal graph. So the slow reveal graph is an instructional routine that promotes sense making about data, and graphs build slowly revealing information. So it's a slide deck, and as you can see from the images on the right-hand side, those are different slides provided for this particular slow reveal graph. And I know the images are small, but you can probably tell there's less information in that first picture, a little more in the second, and a little bit more in the third. And so more information is provided as the slides progress until the full graph is provided at the very end of the progression. So at each stage, educators ask students what they can determine from the current information that's displayed. They ask what they're curious about. And then the best part about the slow reveal graph is that they offer many different graphs that can be used across disciplines and across grade levels. So feel free to use that in any of your classrooms. Next slide. The next tool that we're touching on, which we have also talked about in a previous webinar, is CodeApp. This is a way to build visualizations through a free web app that you can use to explore data and manipulate those visualizations. You don't need any coding experience to use CodeApp, and the website does have a number of tutorials that you can use to get started if you haven't used this tool before. This slide has a few different example lessons from various disciplines. So for example, you can play around with the US population map in social studies. You can explore various types of roller coasters and analyze their speeds in science. And you can determine whether the distribution of birthdays is uniform in a math lesson. So they have a number of different lessons that are available, but I wanted to pick out a couple across different disciplines to show you that this tool can really be used for just about everyone. They have sample lessons for students in upper elementary, middle school, and high school. And so just a quick question for those of you in attendance, you can answer it in the chat. Have you used either a slow reveal graph or CodeApp in any of your classrooms? And if so, how did it go? I'd love to hear that Erin, our expert, is also a big fan of slow reveal graphs. That makes me happy. And I believe we've heard Katrina and Amy talk about how often they're using slow reveal graphs as well. So great. Katrina says that her students are loving to use them. That's wonderful. We have gotten a lot of feedback from educators that this is a really engaging way to help students digest the information in graphs, um, and really help understand kind of all the information that's presented. So,
I think the really neat thing about these tools is when I would have to do like data visualizations, I remember doing it by pen and pencil, like pencil and paper. And sometimes that's really challenging. Like if you mess up, it's hard to have to like redo, you have to redo the whole thing. Um, and so with these tools, I feel like being able to quickly manipulate or like change things quickly and not have to worry about like, oh, I have to start from scratch. And then also being able to see how those changes affect the visualization like instantly. So amazing. I think so many of my students would have gravitated towards being more interested in the visualizations if they had these tools.
yeah, absolutely. Thanks, Sam. Perfect. All right, let's move on to the next slide, please. So now that we've covered a few different tools that you can use for data visualizations, we want to touch on a non-technology approach, and this is tactile data visualizations. Next slide. Our friends at Data Education in Schools, which is part of the University of Edinburgh in Scotland, have some wonderful resources around data physicalization, or what they call data for short. You can tell that they are from the UK from their different spelling of physicalization, which my spell check really does not approve of, but that's okay. So when you're working with students in the classroom, they actually have a kit that is made up of arts and crafts supplies that students can use to create their own data. And you could really use any materials that you can get your hands on, but they have created a list of the supplies in their kits if you're interested in building one yourself. I have included a link to that within the notes of the slides, and these slides will be available for download when they're posted to the Montana OPI site soon. So just know that you'll be able to get to that when the slides are available. All right, next slide. So once the students have these kits, the instructors display a data chart and split the students into groups to start creating their own data. And that is representations of that data using tactile materials. So in this example, the data set was survey data, surveying people about the appropriateness of various behaviors in different locations. For example, behaviors like eating, kissing, and fighting in locations like on the bus, in the bar, in the bathroom, or as they say, the toilet. So as you can see from these two pictures, we have two different groups representations of the very same data, and you can see how different and creative they are. So on the left, you have a representation of appropriateness in the toilet, and then on the right, you have a visualization of appropriateness of behaviors on the bus. And I have to say, this activity was created for K-5 students, but I actually worked through this activity with some colleagues during a workshop last year, and it was just as engaging for us as I imagine it was for the students. So I highly encourage you to use this for any grade level. And I just hope you have a lot of fun with it, because we certainly did. All right, next slide. So on this slide, you'll see another approach to tactile data visualizations, which is data portraits. This is part of a philosophy called data humanism, and that is a human-centered design approach that emphasizes the personal, contextual, and imperfect nature of data. So these pictures are from a 2017 article about Georgia Lupi's work on data humanism. And the article is called How to Draw Your Own Selfie Using Your Personal Data. And the article explains step by step how to draw your own data portrait. And we have linked the article in the slide notes, so you'll be able to get to that. And the first picture is one of the steps, which is telling the artist, or in your case, the student, how to depict their location on their data portrait. So they pick the color that corresponds with the continent where they were born, and they draw a line in that color. Next, they draw a line beside it in the color that represents the continent where they live now. So with your students, you could obviously modify this and use colors to correspond to different data, like which town or city they were born in versus where they want to live when they grow up, for example. And you can see from the bottom picture that for some people, those two lines on the right-hand side of their data portrait are the same color, and that's perfectly acceptable. It's a representation of their data, whether the colors are different or the same. So the other shapes represent other questions asked in the step-by-step directions, such as, are you a morning person or a night person or both? And there's different shapes representing morning person versus night person, for example. I believe those are the moons that you see in different colors. They also ask questions like, do you sing in the shower? Yes or no? And so it's always fun to see the different students' representations of themselves in what seems like an abstract picture, but one that is actually very personalized. So we've actually used this as an icebreaker at different events. We have name tags with some white space, and folks can create their data portraits, and then they can go around and circulate and talk about their data portraits with the other attendees and find similarities or differences. And if Georgia Lupi's name sounds familiar, she is one of the authors, one of the two authors of the book Dear Data, which is a year-long collection of postcards sent between information designers Stephanie Posevec and Georgia Lupi. And it's a delightful book, and we will also mention that a little bit later. All right, next slide, please. And actually, if you'll skip 2 slides, I think we're going to go ahead in the essence of time, interest of time, and go to one prior to that, Sam. Perfect. Okay, so these are just a few more resources that we thought you might enjoy exploring. Data sculptures are exactly what they sound. They are ways that students can represent data in sculpture, but those sculptures can take many different forms. And students have gotten very creative with their approaches, including using a mannequin that was painted to show, represent data on fireworks injuries. So all kinds of different data sculptures. It's a great article that's linked there. The next one is data murals, and these are examples of educators helping their students find stories amongst their data and creating group murals to illustrate the data. So the mural at the bottom of this slide is a great example of a data mural. It tells the story of the food that's been provided and the people who have been fed from the students' community garden. So that is another wonderful example of tactile data that can be really large in this case, or can also be smaller. And then finally, weaving data is another fun approach to visualizing data. This link above is just one example of how this can be done. And you can work with cardboard looms to weave your students' data. So for instance, if you were working on a data visualization with them about the color distribution of Skittles, for example, then perhaps you create a loom and you weave the data about that color distribution. So if you're interested in weaving with cardboard looms, they can be purchased at Hello Looms, or you can make your own out of cardboard via the link that is provided. And I will mention that the Hello Looms site also offers great weaving examples that you can use with your students and by which they can represent their data. So in the notes for the slides, I've included a couple of examples of how you can do this with your classes. In a K-3 classroom, you might have one large class weaving project to show students' preferences, for example. In a 4-6 classroom, you might have an individual or a class weaving project on tracing endangered species throughout time. In 7-8, you might have projects on personal data or perhaps on the weather, tracking weather data. And then finally, in grades 9 through 12, you might have individual weaving projects on voting, sports, weather patterns, or even poetry annotations. We've seen some really good examples of all of this. So in the speaker notes, you'll see all kinds of different links to those different resources that you can utilize. All right, so we'll move to the next slide. So overall, we just want you to understand there are so many ways you can visualize data, and there are even more ways to do it, even beyond the ones that we have shown in the slides. I've included a few other ideas in the speaker notes of this slide, including a site called The Pudding, which is a fun one. It's all about sort of pop culture and different data visualizations, storytelling through different graphics. There's one called Plotting Plots, which is all about using numbers to better understand literature. And then I also have a list of books that you might be interested, including Dear Data that we touched on earlier. There's one called the K-12 Educators Data Guidebook and one called Data Story. So we really hope that one of these resources piqued your interest and got you thinking about ways you can visualize data with your students. So we hope you will enjoy one or many of these and just be creative with your students. So thank you. And Sam, I'll hand it over to you.
Great. We've got time for a Q&A, and I am super excited. Erin, I would love for you to go off mute. I have a question for you. I was going through your library because after seeing the T-Rex, I was like, oh my gosh, what other fun data sets are there? And I saw some really neat ones related to music and sports, and I think so many students could really gravitate towards those. Are there other, like what are, I know you showcased three, but besides the three that you showcased, are there any other ones that you are just super excited or you think students would see and be like, oh, that's a topic that I didn't think of originally, that maybe I want to explore into?
Yeah, so there's 176 data sets in there, and there really you can find something for a lot of different interests. One that has been our most popular that broke all records that we had was it's called the Taylor Swift effect, and it's a very serious look at the performance of the Kansas City Chiefs, comparing games when Taylor is in attendance versus when Taylor is not in attendance. So that's a fun one. There is one that's in there that might be timely with the holiday season coming up, looking at plays of Mariah Carey's All I Want for Christmas, or in different countries around the world, and looking at where is that song popular and where isn't it popular. There's a grandma says Thanksgiving dinner is gets more expensive every year. Is she right? So looking at data and inflation over many years. So there's a lot of different things to explore in that resource library. I definitely encourage people to look around in there.
Yeah, I love the vast like topics that you have presented because I really do feel like any student could find something that they're interested in. I could really see the one with the Taylor Swift, your sports enthusiasts and then your Taylor Swift fans really arguing between that and their different perspectives. So that's just so much fun in the classroom. I'd love to open it up to anybody else that might have a question for Erin or Lee Ellen, connected to data visualization. Perfect. Well, since there aren't any, let's go ahead and just kind of wrap things up for the night. Just wanted to share that the next session for December is actually going to be asynchronous. It will be available on the OPI's website on December 1st, and you will have until January 12th to finish the activity that's associated with the webinar in order to receive your credits. And so we're really excited. We hope that you enjoy participating in the event and that you guys have a wonderful winter holiday. Reminder to complete the evaluation form in order to get your professional development unit certification from OPI. If you have any questions, please feel free to reach out to us. We hope you guys have a wonderful evening and thank you again for joining us.